In this video, we will learn about few more configurations related with your Oracle Weblogic server architecture. So let us do a quick recap of the Weblogic server architecture. A user is there, and it is supposed that it tried to access some website with the help of a browser. Okay, then the request from internet or maybe from the internet network goes to your load balancer, and from load balancer, it redirected to any one of your backend web server. Okay, based on the algorithm that has been defined at load balancer level, and then your web server redirect the request to your backend WebLogic servers, and then from WebLogic servers the request can go to your database instances for the data, right? And this is the configurations for the high availability. That means we have multiple nodes there. So as of now, in figure, you can see the 3 nodes are there for high availability. Okay, and then for scalability as well. For example, today you have a user base of 1,000, and then tomorrow it is going to be increased. That you need to scale your system as well accordingly. Maybe your web server, your application server, your database instances, because the user loads is also getting increased. So you can scale your system easily. Load balancing is how you will are diverting the traffic, okay, from maybe from load balancer to your web servers, and then from web server to your application server, and from application server to your different database instances. And then failure, like in case one server goes down, then your session should transfer to some other running node. And the benefits of load balancer, what we have discussed in the session 1 and 2, is about the SSL termination, that you can configure your SSL at the load balancer level. It is not required to configure at the web server or maybe at the WebLogic server level. Okay, and then session stickiness, that if a user is connected to any one of the backend server, till the user is there, all the requests from that user will be get connected to that particular node only. Let us extend the discussion, okay, about when a user accesses a website, okay, then there's a one more component in between, which is called a DNS server, which is called a domain name server. So what exactly it is a DNS? It is a resolution services, okay, you can say resolution services, okay, that convert your DNS name to your IP address. Okay, for example, we access the google.com, okay, and there is a corresponding IP of the google.com DNS name. Okay, so if every organization will start roll out the IP address instead of a DNS, then it's not possible for human beings to remember the IP address of their organization. Okay, and domain names are easy to remember, but IP addresses you can't remember, right? Always. So that's why, to make this process easy, okay, this domain name came picture, so that, okay, so the domain is for the end users, okay, and as I said, for example, google.com, facebook.com, amazon.in, okay, these all are the domain names. Okay, so whenever we hit any access any website with the help of browser, okay, then we enter the DNS name, okay, and that DNS name reach to the DNS server, and that DNS server convert that DNS into the corresponding IP address. Okay, this is the work of DNS server. And then once that DNS server convert that DNS to IP address, and then it look for the corresponding backend load balancer, or you can say corresponding backend server, okay, which is running on that particular IP. Okay, so in most of cases it could be a load balancer in the backend. Okay, so the request reach to your load balancer from the DNS server, okay, and then from DNS server it can route it to your backend web servers. Okay, and then from backend web servers, the request diverted to your backend application server and database levels. But when we talk about the load balancing algorithm at load balancer level, how it load balance the request to the backend web servers. Okay, so there are certain algorithms. The 3 algorithms are there when we talk about the Oracle OCI. But mostly these algorithms are same for other load balancers as well. Okay, so 3 algorithms are there for Oracle OCI. One is the round robin, second is least connections, and third one is IP hash. So what exactly round robin? Okay, so when we talk about round robin, is that means it sends the request to all the backend servers one by one. Okay, for example, if we have a request 1, the user 1 is trying to access the website, it will go to node 1. And if second user trying to access the website, it will go to node 2, and similarly third request will go to node 3. And then again, fourth request will go to again node 1, and then furthermore, all the requests will go in the same way. That is called a round robin fashion. Second is least connection. So that is very straightforward. Like if a request is coming to your load balancer, then it check for the number of sessions to the backend servers, and wherever it will find the least number of connection, it will send the request to that particular node. So it's try to balance the request to the backend server. So you can say it try to balance the number of sessions to the backend servers. Okay, and when we talk about IP hash, it divert the request based on a particular IP of the user which is trying to access the website. Okay, it keep track the status of the IP address, and then suppose that and a user is connected to node 1 with the IP address of x.x.x.x. Okay, so that every time that user will try to access that any backend servers, okay, for entire transactions, that that IP hash algorithm will always connect that IP address to the same backend application server for the processing. Okay, and these are the three algorithms for your Oracle OCI. Let us extend the discussion. Okay, and now when your load balancer send the request to the backend web server, and then from web server it goes to your backend WebLogic server, or you can say about the application server. Okay, so for sending the request from web server to your backend WebLogic server, there is a term, or you can say the software module, which is called a web server plugin, which is shipped to your WebLogic server. Okay, so this web server plugin is used to forward the request from your web server, which is Oracle HTTP server, or also called as OHS server, okay, to your WebLogic server with the help of WebLogic server plugin. So what exactly is plugin? It requests to a WebLogic server usually go through a web server or a load balancer, which serve as a proxy for the client request. When the WLS, that means WebLogic server, requests are front-ended by either a web server or a load balancer, the requests are handled via the plugin. So whenever a request from your OHS or your Oracle HTTP server need to be sent to your backend application server, which is a WebLogic server, then requests go from the WebLogic server plugin module. Okay, so WebLogic server, or you can say web server plugin, is an HTTP reverse proxy plugin that allow you to instruct a web server to forward certain HTTP requests to another server. Okay, so that means it does a simple round robin between all available servers. So this is the default algorithm with the web server. It will send the request to the backend available application servers in request in the round robin fashion. And let us see about some important parameters of WebLogic server plugins. Okay, so WebLogic server plugins parameters are defined in two important files of your web server. One is httpd.conf, and second is mod_wl_ohs.conf. Okay, so whatever the parameters we define under mod_wl_ohs.conf file, okay, it is called inside your httpd.conf. Okay, what does it mean? The second file is called under the first file. So the file mod_wl.ohs.conf, it is called under the http.conf file. So whatever the parameters that you are defining in mod file, it will be called from the httpd file. Okay, so all the redirection from the web server to the backend WebLogic server, or maybe some other application servers, okay, that we defined in the mod_wl_ohs file, and this is the file which is you will find with the Oracle HTTP server. So what are some important parameters for that one? The first one is the WebLogic cluster parameter. Okay, for example, in the backend you have 2 or 3 or maybe more than that number of servers are running behind your web server. Okay, and you want to forward the request to all of the application servers. Okay, then you can define a WebLogic, or not WebLogic, but web server plugin parameter, which is called WebLogic cluster. Okay, and you can see the example. Suppose there is an application which is deployed in your WebLogic server, and this application is a context root of /shopping cart. Okay, that means a user can access the website from the browser with the context /shopping cart. That means DNS/shopping cart. Okay, and as shown in example, this application is running on 2 nodes. One node is the DNS name xyz.mymachine.com, and then second one is abc.mymachine.com. Okay, and the WebLogic servers are running on port 703 on node 1, and same 703 on node 2. Okay, then both the servers and ports are defined in your WebLogic cluster. Okay, so by this your web server will send the request to any of the backend application server, okay, in round robin fashion. Second is the WebLogic host. Okay, and for example that you do not have a cluster of servers. Okay, or maybe you have a singleton services that web application, okay, that is deployed on only a single managed server, or maybe on the admin server. Okay, for that you can define the WebLogic host parameter. For example, you know that WebLogic admin console is deployed on your admin server, and that means it is deployed on only one single server. Okay, right? So basically by default it run on the port 7001. So if you wanted to configure, like, to access your WebLogic console, from the load balancer, okay, then you can define the WebLogic host because it is running on a single DNS or single IP address. Okay. And then the last important parameter is dynamic server list. Okay. So as you know that web server send the request to backend application servers. Okay. And suppose that in a case or in a moment, if any of the server is not responding, okay, and maybe crashed, okay, then web server look for all the running servers in the backend, okay, when this parameter is on, and then it remove the server which is not responding from the dynamic server list. Okay, that means it will send the request only to the active servers. Okay, if this parameter is off and suppose that any backend application server is not responding or make a crash, okay, then the server will keep try to connect that server, and the end user request may get timeout in that case if it will not get the response from the backend server. So if this parameter is on, it will not try to connect to the backend server which is down or maybe not responding. So it is always recommended to let this parameter be on in your all the environments. Okay, and then when we talk about that we are configuring the WebLogic plugin or web server plugin for forwarding the request from web server to your application server, which is a WebLogic server, then in that case, okay, to make your WebLogic server also aware about that when it has to get the request from the web server, you need to enable a one parameter which is called a WebLogic plugin parameter. That plugin parameter need to be enabled on the WebLogic server as well. Okay, and it is there inside your server configuration and web application option, which is shown in the picture. Okay, and then from there you just enable this WebLogic plugin enabled. And now when we talk about the connection from your application server to your backend database, okay, then there is a term called JDBC driver. Okay, so it is a code or a software which is used by WebLogic server to connect with the database instances. Okay, that is called a Java database connectivity. Okay, so it is a software component that is used by the Java application to connect with the backend database servers. Okay, and the JDBC drivers that are installed with the WebLogic server are OJDBC 8.jar, 7.jar, and 6.jar, based on the which WebLogic server or which JDK you are using. Okay, so if you are using JDK 8, then you will see a driver of 8.jar, and if you are using a JDK 7, then you will see the file 7.jar. Okay, which will be used to connect with the database. And when we talk about to get or to create the connections from your application server to a database, then you know for that the entity is called data source. And one more important data source introduced in your policy is active grid link data source. Okay, it has a lot of enhanced capability that has been specifically designed to work with the Oracle RAC cluster, where you have a real application cluster of Oracle database. So you have multiple nodes of a database in the backend, and your data source connect with your backend different instances. Okay, so to provide different kind of a enhanced feature that has been incorporated in your Oracle database, this active grid data link data source has been designed. Okay, so this is specifically designed for the RAC. Okay, Oracle RAC. So when we connect with the backend server, so you have two options to connect with the database with the help of data source. One, if you have multiple instances, then you can define the IP address of each host separately. Okay, for example, if you have 3 hosts, then you have to define the 3 entries, host equal to then IP address of node 1, then host equal to IP address of 2, and then host equal to IP address of 3, right? But there's another option that is called a scan address. So scan address is a single DNS name, okay, which do the load balancing of the request to the backend database instances. So that means you don't need to define the multiple host and IP addresses in your connector descriptor. Okay, so you have to define only a one DNS, which is called a scan IP or a scan DNS. Okay, and it will automatically route the request to your backend. Okay, this is the functionality at the database level. So as an WebLogic administrator, if you are configuring active grid link data source, okay, so you have to instead of defining the multiple IP address or a single IP address for a data source, you can just define the data source, or you can say the listen address of your data source as the scan IP address. Okay, and it will direct or it will load balance the request to the backend multiple database instances. Thanks for watching this video. Make sure to subscribe the channel, and I will come up with some more interesting videos shortly. Thank you very much.